Hey guys, welcome to another Tech Talk. Today we're gonna have the wonderful Bree and Jane talking about TypeScript. Everyone, let's unmute ourselves and give them a round of applause. Let's go!
Yay!
We did it, guys. All right, take it away, guys.
Okay, hi everyone. Our names are Jane, Kim, and Sabrina Goldfarb, like Jiho kindly introduced us earlier. Welcome to our Tech Talk. This talk is sponsored by Codesmith and Single Sprout. So today we're going to be talking about the transformative world of TypeScript and why you should learn to use it. As you can see in our table of contents, we will be going over what TypeScript is, doing a quick review of JavaScript specs and why TypeScript is such a desirable language in comparison, showing you a quick demonstration of TypeScript, talking about real-life uses in terms of what companies use TypeScript and what technologies you can use TypeScript with, and summarize the pros and cons of TypeScript for you. We'll also be showing you a couple of resources on how to get started about learning about TypeScript, and we'll be also taking questions at the end of our presentation. So, what is TypeScript? According to the TypeScript docs, TypeScript is an open source language which builds upon JavaScript, one of the world's most used tools, by adding static type definitions. So TypeScript is commonly described as a strict superset of JavaScript that adds static type checking and behaves like a compiled language. Let's break that down really quick. TypeScript being a superset of JavaScript means that it adds functionality to an already existing language. Think of TypeScript as like a top layer on top of JavaScript or like a dialect of JavaScript. TypeScript also goes through a process called compilation, which allows programmers to check for errors before runtime, as opposed to in JavaScript, where you have to wait until runtime to see errors. We'll go through more about how TypeScript diverges from JavaScript in a bit. Let me also just show you a couple facts about TypeScript before we dive into it. TypeScript was developed and released by Microsoft in 2012. And it continues to be maintained by Microsoft to this day. It's actually they're actually very good at updating TypeScript. The most recent significant release was actually just last month in November 2020 with version 4.1.2. TypeScript was built specifically to help discover bugs earlier during development with that compilation tool, so that building large-scale applications became more efficient. Because JavaScript is a dynamically typed language, you have to wait until runtime to see the errors, like I said earlier. But with TypeScript, you can see errors in your IDE as you code. So let's talk about what TypeScript does. TypeScript adds static type checking to a loosely typed language, like I just said, which means it allows you to assign types to variables in your code, as opposed to JavaScript being a dynamically typed language where checking happens at runtime. TypeScript is compiled into JavaScript in order to enable JavaScript engines to read TypeScript code. Because JavaScript engines are unable to read TypeScript code, you have to download a compiler which can then transpile it down to JavaScript to be used in production. Essentially, you'll have a TypeScript file that you've written out, which the compiler then takes and makes into a JavaScript file that can be then used in production. Also, a great feature of TypeScript is that if you already know JavaScript, you know a lot of TypeScript, because TypeScript is built on top of the language and essentially, like I mentioned earlier, is a dialect of JavaScript. You already know about like 90% of what you need to know. So why the need for TypeScript? JavaScript is an extremely successful technology. It is literally the #1 used language on GitHub, but it is an old language because JavaScript first appeared in 1995, like, a while before TypeScript was even a twinkle in anyone's eyes. And remember what the internet looked like back then? we don't really want that anymore. Another thing is that, like I mentioned earlier, JavaScript is a loosely typed language. It's really easy to make syntax errors and logical code errors without really realizing what you're doing at the time. We use TypeScript because it makes it easier to refactor code, and we want our code to become well-structured, and we want to improve auto-completion. In fact, one study showed that 15% of JavaScript bugs can be detected by TypeScript. Maybe that doesn't sound like that much, but imagine how many hours of time that can save a company or an individual developer. So I'm just going to pass it off to Bree so that we can look at code examples and then go into a demo.
Hey guys, so before we go into our demo, let's take a quick look at a code example. So anyone who knows JavaScript should understand our first code block, which is basically JavaScript inferring our type based on the variables we've placed in our object. Using TypeScript, we can explicitly describe this object shape using the interface declaration. Then if we go to the next slide, you can declare that your object conforms to the shape of your interface by using syntax like :type name, in this case, user with a capital U, after a variable declaration. If you do this and you provide an object that does not match the interface you provided, or if you provide an object with a key that does not exist in the interface, TypeScript will give you a warning. How convenient is that? So now we're going to go into a live demo and we're going to get hype about types. So the very first thing we're going to do is share my screen. Just give me 1 second to get my code up here. All right, everybody good? Everybody can see my screen? Perfect. Okay, the very first thing that we have to do, as we all are used to, is npm install. So we have to do an npm install of TypeScript. We'll give that a second to run. All right, so now we're going to take a look at some of the differences between JavaScript and TypeScript. So not surprisingly, the basic types of TypeScript are pretty much the same as they are in JavaScript. So first, we have Booleans. So the uncommented code is going to be our TypeScript code, and the commented code will be our JavaScript code for your reference. So we have Booleans. We're also going to show you we have numbers. We have strings. We have arrays. Let me make this a little bit bigger so everybody can get a nice little look at this. We have Booleans, numbers, strings, arrays. We have tuples, which aren't widely used in JavaScript. JavaScript uses tuples as arrays. But if you've seen other languages like Python, you know about tuples. And then we also have null, undefined, and we have objects. So now we're going to talk about one thing that we have on top of this. So there's an additional basic type, which is called an enum. And for anyone who knows any C#, this is going to look really familiar to you. So let me show you what an enum looks like. Okay, great. So an enum gives more friendly names to a numeric set of values, or pretty much any set of constants, but in this case, we're going to be talking about a numeric set of values. So if it's not defined, enums begin their numbers at 0, kind of like an array does. So when we look at our variable c, we're going to see that it would console.log to the number 1. We can also set where we want these values to start by telling TypeScript that red should be 2, and then red would be 2, green would be 3, and blue would be 4. Also, we could declare each of these as whatever we wanted. So if for whatever reason we needed to save the numbers 4, 16, and 24 in variables, we can make red, green, and blue equal to those respectively. So now we're going to talk a little bit about unknown, any, void, and never. So let's start with unknown. Let me just put this up here for you guys. Okay, so unknown tells the compiler that we could be anything. So we're not going to get a warning when we change our who knows variable from a number to a string. Then we can use any. So any is a way to easily convert all of your code to TypeScript, but please don't do this because we're saying we're opting out of type checking basically. So this is great for parts of legacy code where you aren't exactly sure what your code is doing or if a variable could be changed, but you don't want to use this in all of your code because it kind of defeats the purpose of using TypeScript. So next we're gonna look at an example of void. There's a little bit of void, perfect. So void is literally the opposite of any. Whereas any says it can be all types, void is literally the absence of a type. So this, like we show, is usually seen in functions that have no return value. There's also never, and never represents the types of values that never occur. This is widely used in infinite loops, and exactly why I'm not going to show you our code for never, because I don't want to accidentally crash my laptop during this whole demo. But basically, you could say if your loop was going to end out because your number was going to equal 1, you could say, never let this be a number that equals to 1. So now let's talk really quickly about objects. An object is a non-primitive type, as we all know. And in TypeScript, you're generally not going to need to use this. You will need to identify the primitive types within your objects, but declaring the object itself is something that you're not going to have to worry about when you're just starting out with TypeScript. So lastly, for our demo, we're going to look at some key principles of TypeScript and see what warnings pop up in our IDE. So we saw a demo of interfaces in the slides, and for the sake of time, I'm not going to go over those again, but let's take a quick look at functions. Here we go. So let me add a couple of console.logs to this function. And now you can see that there's a squiggly line. So this is a function in TypeScript, and there isn't much difference with JavaScript, except that we can see that our parameters are now typed. If we try to console log our add function with the proper type, nothing happens. But if we try and console log our add function invoked with the wrong type, we get an error. And this is the error that we would get. Warning, argument of type string is not assignable to parameter of type number. Next, we're going to look at union types. Beautiful. Okay, so a union type is where you can have one type or another. So in our example, let string or number is a nicely declared variable that lets us know we can have either type string or type number. When we set this variable to the string cohort, we get no warnings. And if we reassign it to the number 22, we still get no warnings. You'll notice, however, that we do get a warning when we try and reassign it to an empty array or a Boolean. This warning is going to say this. Warning, type Boolean or type array is not assignable to type string or type number. So can you start to visualize where this might come in handy in your code? Let's discuss one more thing in our demo. So here we go, variable assignment. We have a variable that we've assigned to 1, and then we try to assign it to the string 1. You'll notice that we get a warning like we expect to. And again, when we try and reassign it to an array, we get another warning. But if you were to console.log our variable, you're going to see that it was reassigned to this invalid type. While TypeScript is showing us our errors, it's not breaking our code when we run it after we've made these mistakes. TypeScript is going to help you identify these bugs, but it's not going to stop you from making these errors. So now that we've gone through a little demonstration, I'm going to stop sharing my screen and we're going to talk a little bit about some pros and cons of TypeScript compared to JavaScript. Awesome.
All right, what an excellent demo by Bree. Okay, so now let's go into some pros and cons. All right, so some of the pros and cons of TypeScript compared to JavaScript are as follows. TypeScript is supported by most IDEs, including VS Code, which I know most of you guys use, making it really easy to catch and debug errors while coding. It easily transpiles down to JavaScript, so any browser or platform that works with JavaScript is going to work with TypeScript, and it supports all of the object-oriented programming concepts of JavaScript. It's also cross-platform, cross-browser compatible because of the compiling function, and it's really, really similar to JavaScript, like I mentioned earlier. And so JavaScript developers will pick it up really, really quickly. Some of the cons that it is comparatively difficult to set up if you really want to, because you have to install the compiler, and because it has the needs for type guards, which we didn't have that much time to get in today, but it's just what Bree said earlier about you can still make logical errors in TypeScript because it still allows you to reassign types, even though it shows that it's an error. It's that kind of thing. You have to assign type guards in order to make it not happen at all. Another con, this is just a sort of, is that it can be seen as cluttered and harder to read if you are not used to seeing all the types on your screen, but actually it just makes it a lot easier to read once you're used to it. Lastly, because it's not a true static type language, there can be errors that occur in compilation as it tries to extend JavaScript and give JavaScript features of a statically typed language. Okay, so now let me show you some real-world examples of using TypeScript. First, you're probably wondering what companies even use TypeScript. Is this applicable to me, like I already know JavaScript? But as you can see here, TypeScript is used by Microsoft, Google, Slack, Airbnb, Medium.com, Trivago, DoorDash, and many, many more companies. This is just a short list of like some of the more high-profile companies that you probably have heard of, but you can find so many more on Stackshare.io and LinkedIn.com and many other websites. In fact, you can actually go on TypeScript's documentation website, typescriptlang.org, to see articles and videos from top-level software companies who have successfully migrated to using TypeScript. Or maybe you are a bit worried about what technologies we can use with TypeScript. Maybe you've gotten very comfortable with using some frameworks with JavaScript and you're worried about whether you can use them with TypeScript. Well, no worries about that. TypeScript is supported by Angular, Vue, Jest, Redux, Ionic, Dino, GitHub, so many more. Pretty much anything that you can use with JavaScript, you can also use with TypeScript. TypeScript has also been slowly but surely rising in popularity in the last 8 years that it's been out. So while JavaScript still reigns supreme in its position as #1 in popularity in terms of GitHub pull requests, TypeScript has shot up from #7 to #5 just within this past year. Now you can see that in the top 10 rankings, it's ahead of C++, Ruby, PHP, C#, and C. And there are so many pros to using TypeScript that, considering just how popular it is and it is becoming, and just how similar it is to JavaScript, if you're already a JavaScript developer, you have absolutely nothing to lose if you decide to learn how to use it on top of your already existing JavaScript skills. Lastly, I just wanted to show you, these are the resources, or some of the resources that we used in order to research for this presentation, but there are so many more out there. Some of the ones that really helped us were the TypeScript docs and the TypeScript Deep Dive, which was a book by Basar Ali Sayed. You should definitely check those out if you're interested in TypeScript. And there are so many Medium articles and YouTube tutorials out there if you really want to get into it. And here's our contact information for both Bree and me. Our GitHub and LinkedIn pages are here if you want to contact us about anything. And now we'll open the floor to questions.
Awesome. Let's give a round of applause to Jane and Bree. And I see Shaw, you have a question? Go for it.
Yeah, awesome presentation. I was just wondering, would you recommend for someone who's currently learning JavaScript to also simultaneously be learning TypeScript?
Yeah, I can take that question. I would recommend that you get a strong foundation on JavaScript before jumping into TypeScript. But if you feel that you're ready to learn another language or learn like a dialect of that language that you're already learning, go right ahead. It's such a terrific skill to have, and more employers are looking for this skill. So it would only be a plus to you.
Jordan, go for it.
Yes, that was such a great presentation. I was wondering, you mentioned a lot of these big companies that use it. But one of the cons is that, it can be complicated to set up, and we just started using it for our project. But do you think for smaller scale projects, is the juice worth the squeeze, like in using TypeScript, or is it just better suited for larger scale companies and projects?
Yeah, I could take that one. So definitely great for large companies because it can save them literally thousands of hours in code. But even if you're a small developer working on a small code base, that doesn't mean it can't help. So instead of having to run your program constantly, imagine if you could see all of your errors right from your IDE. Doesn't matter whether you're spending 20 hours on a project or 2 million, it's definitely going to be helpful.
Hey guys, so first of all, awesome presentation. That was really amazing. My question was, like, at one point you mentioned that TypeScript won't break the code if you have the wrong type in there. Was that only for untyped or was that for all of TypeScript? And if it's for all of TypeScript, is it meant more just to help you locate stuff when debugging rather than prevent bad code from running?
Yeah, so TypeScript, it's not going to break your code, but you really want to have typing in there for safety's sake, because especially with the compiler, there are a lot of things that can go wrong. So you could do worst case, what some people have done in the past is just typing everything as any or unknowns and things like that. Definitely not recommended, and it's definitely not recommended to use TypeScript unless you actually plan on declaring your types, because there are issues that can still happen in compilation.
Awesome. Any last questions? Great. Let's give a final round of applause to Sabrina and Jane for an awesome presentation. Well, everyone enjoy the rest of your day.